Welcome to the recorded version of the HA100 SAP HANA Introduction training course. My name is Michael Mirbo, and I work for SAP Sweden Field Services as a consultant. I hope you will enjoy and benefit from this course, and I also hope you will find HANA to be as interesting and groundbreaking as I do. So this is now Unit 1, Introduction and Positioning to HANA. What does HANA stand for? It stands for High Performance Analytic Appliance. So what we're going to see is what we can make out of this acronym. The goal of this full course is to get an overview of SAP HANA Appliance, understand the architecture, and also learn how HANA provides new ERP analytical capabilities. So this is the first unit, Introduction and Positioning. We're going to see the ideas behind HANA and why there is a need for HANA. After that, we're going to go on to see a little bit both about the end interface to HANA, the HANA Studio. We're also going to see what's under the hood, as in the architecture. Then we're going to move on to data provisioning, which is how to deliver data into HANA, which when it comes is empty. We need to fill it with data from somewhere. Where can we provide it from? Then we're going to move on to modeling, so how to enable HANA for reporting. And finally, we're going to look at reporting from an end user's point of perspective. Let's start with the introduction to SAP HANA. All sorts of things can be stored digitally. In fact, there's been an information explosion recently. Massive amounts of data is being created every year, and how fast your business reacts to it determines whether you succeed or fail. This is a big problem. It's getting bigger. IDC estimates that worldwide digital content added up to 487 billion gigabytes in 2009. They predict this will double in 18 months, and every 18 months thereafter. It's like a stack of DVDs all the way to the moon and back. In Sloan Management Survey in 2010, 60% of executives said their companies have more data than they know how to use effectively. With data doubling every 18 months, that percentage is going to keep growing. According to EMC, by the end of 2011, there was 1.8 zettabytes of digital data. 1 zettabyte is 1 trillion gigabytes. If you think about your own situation, do you see yourself in this picture? How much data do you store in your home in the form of pictures, video, music, and other media? And how much do you store at work? How much does your department store, your organization? Do you see the growth continuing or slowing down? At the same time, the consumerization trend is driving up expectations as to what enterprise IT can help the business to do. People want instant access to information in the moment, whether that is a moment of risk or a moment of opportunity. If the moment has passed and your business has not taken the right action, it has failed. People want instant answers. They want them to be right. They want them to be anywhere, anytime. People have become used to online search engines, smartphones, online applications. In many of these, there is no real delay. Answers and interactions are held immediately to the user. And that's not enough. It should be accurate and up to date. This puts IT in a tough place. IT cannot deliver what the business needs. Why? Because the cost of managing that data explosion is way too high. Because there is no practical way to instantly analyze everything that's going on relative to the business, IT can deliver some of the information. The most critical slice of information can be delivered in near real time, but that's not enough. Data is growing, demand is increasing. I'm sure your organization has reports that are either using out-of-date data, or when refreshed, you're stuck with your mouse pointer transformed into an endless hourglass. We must find a way to deal with this, a way to process and analyze massive amounts of data in real time. But this is the role of SAP HANA. Using groundbreaking in-memory hardware and software, we can manage data at massive scale, analyze it at amazing speed, and give the business not only instant access to real-time transactional information and analysis, but also more flexibility. Flexibility to analyze new types of data in different ways without creating custom data warehouses and data masks. Even the flexibility to build new applications which were not possible before. In this diagram here, we see it mentioned here 3,600 times faster analytics. Is that really possible? Well, hold on to that question. There is, in fact, certainly enough under the hood of HANA to deliver. It's not just a sales pitch. So what is inside HANA? Well, this architecture diagram explains the main components and capabilities. We have in-memory software and hardware. The hardware is delivered by vendors such as HP, IBM, Fujitsu, Cisco, Dell, Hitachi, or NEC. We've got data modeling and data management for the large amount of data to be useful. We have great tools to model and manage it. It's also possible to provide either real-time replication or SAP data services or ETL capabilities where real-time might not be needed or where you need a lot of transformation to the data that is to be loaded. So we keep throwing around words like massive amounts of data and amazing speed. What kinds of scale, speed, and improvements are customers seeing that are using HANA? Remember what we said to hold on about the question about 3,600 times faster. Well, here are some proof points. One of our pilot customers reduced the time it took to run a report from 1 hour to 1 second. That's 3,600 times faster. Let's put that into some perspective. SAP talks about helping you to run better, so let's use that as an example. When an average person runs, they go about 7 miles per hour. 3,600 times faster would be about 25,000 miles per hour. That is the fastest any human being has ever traveled, and it was only done once by the astronauts on Apollo 10 on their return from the moon in 1969. During testing for HANA, we ran queries against 460 billion rows of data in less than 1 second. That's like being able to analyze every repair and service visit for every car on the earth in the last 12 months in 1 second. Or it could be to process every address that everyone alive today has ever lived at in 1 second. Or to calculate the amount of taxes paid by everyone on the planet since 1950 in 1 second. Having the ability to create new real-time processes and simplify your IT landscape has big impact. According to a study by Oxford Economics, companies that implement real-time systems see an average of 21% revenue growth and a 19% reduction in IT costs. Let's see another real example here. This is a large bank with 1 month of customer information. Now, in this example, no schema changes were made, same data, same SQL, and we saw immediate benefits. This was without modeling. So we can probably guess this would have been even more enhanced if this would have been applied as well. So in this first graph here, we can see that data compression was down 6.3 times compared to a traditional database. and these query runtimes comparisons, they actually show up to 369 times average query speed up. For new businesses, a new reality provides new challenges. Why would you want to wait? All customers want to see their current business's data made immediately in real time. Nobody wants to wait until data is uploaded into BW if necessary. Why wait for new systems? Latest hardware and latest database technologies already now support real-time reporting on massive amounts of data. Don't lag behind. We need something proactive, not reactive. If you just lost millions of dollars in one way or another, you need to find out immediately why this is happening. Waiting for a data warehouse to refresh overnight, I might not cut it. Let's look at the naming in and around HANA. SAP HANA Appliance Software is a hardware and software combination that integrates a number of SAP components, including the SAP HANA database, SAP LT, stands for Landscape Transformation, the replication server, SAP HANA Direct Extractor Connection, as in DXC, and Cyber Replication Technology. The SAP HANA database itself is a hybrid in-memory database that combines row-based, column-based, object-based database technology. It's optimized to exploit parallel processing capabilities of modern multi-core CPU architectures. With this architecture, SAP applications can benefit from current hardware technologies. Additionally, we look at this diagram. Here we got the SAP HANA Application Cloud, which is what we call HANA when it's deployed into a cloud-based environment. We also have applications. Applications could potentially be powered by HANA. You see an example here would be called SAP Smart Meter Analytics, powered by SAP HANA. Finally, we have the studio here, which is the cockpit or the control station of HANA, where you can model, you can administrate, you can deal with security, anything really in relation to administrating and modeling on your HANA database. So, we keep talking about this massive growth of data volume. It causes daily challenges currently because data is not just in one place. We see very complex system landscapes. We all have skilled workforces in our organization. They have high expectations. They want immediate results. Furthermore, they want high flexibility. They are not happy with static printed reports. They want the ability to be flexible and to be able to analyze it. So these are some of the challenges that SAP has spotted in the organization. This has spurred the development of HANA. Before HANA, with the traditional methods, we saw the following consequences. Suboptimal execution speed, lack of responsiveness, endless hourglasses, timeouts, user frustration. No wonder the user would go on Google and get an instant answer to a query there. How come you couldn't get that with your own organizational reports? As a response, we were trying to work around unsupportable business processes. Might give us lack of transparency. There was a need for aggregation, or the other way around, need for drilling down. Figures might have been outdated. What good is that when you want to see real figures? You have to guess the current situation. The business model would then be reactive instead of proactive. This would cause missed opportunities and a competitive disadvantage. Moore's law was initially formulated in 1965. According to this law, the number of transistors in a chip doubles every year. However, in 1975, this was adjusted by David House, who said it would double every 2 years. And a widespread variant of Moore's law now states that the transistors will double every 18 months. Still, with this in mind, be sure that hardware innovations have caused processing power to grow exponentially. We can now have, in a HANA box, multi-core CPUs. For example, 10 cores in a CPU. A core is the part of the CPU that performs actual instructions. We could have multi-CPU boards or blades, maybe 8 CPUs per board, multi-server boards. So big racks, we could have up to 320 cores and more with 4 terabytes of RAM and more. This is made possible because there's been some improvements in technology. For example, in CPUs between 1990 and 2010, we've seen 143 times improvement. In memory, we've seen 250 times. Addressable memory, 2 to the power 48 times improvement. And network speed, 100 times improvement. Moreover, disk data transfer, 25 times improvement. Do you spot something interesting here? Disk transfer has not really kept up to speed with improvements in memory speed or addressable memory. Historically, database systems were designed to perform well on computer systems with limited RAM. This had an effect that slow disk I/O was the main bottleneck in data throughput. Consequently, the architecture of those systems were designed with a focus on optimizing disk access, i.e., by minimizing the number of disk blocks or pages to be read into main memory when processing a query. Computer architecture has changed in recent years. Now, multi-core CPUs are standard, with fast communication between processor cores, enabling parallel processing. Main memory is no longer a limited resource. Modern servers can have 2 terabytes of system memory. This allows complete databases to be held in RAM. Currently, server processors have up to 64 cores, and 128 cores will soon be available. With this increasing number of cores, CPUs are able to process increased data per time interval. This shifts the performance bottleneck from disk I/O to the data transfer between CPU cache and main memory. So how do we make sure that we in the database prevent the bottleneck experienced when CPU is sitting idle waiting for memory to be loaded into cache? One of the key components that HANA introduces to make sure we don't sit idle with the CPU is the columnar data storage. So the concept of columnar data storage has been used for quite some time. It's not brand new. Historically, it was mainly used for analytics and data warehousing, where aggregate functions play an important role. Using column stores in OLTP applications requires a balanced approach to insertion and indexing of column data to minimize cache misses. The SAP HANA database allows the developer to specify whether a table is to be stored column-wise or row-wise. It is also important to alter an existing table from columnar to row-based and vice versa. So what is the difference? In a row-based storage, rows are stored in tuples. In a column-based storage, we see columns here contain the information that are in the rows, but they are stored in a different way. We look at customer here. We've got customer ID 100, we've got 200 and 300. We would only store the distinct values in this column. We would store 100, 200, and 300. For country, we would store DE, US. You see it's an even smaller column here. Product, would store 2 values again. Product 1, product 2. Amount, here we would have 4 distinct values. So it's a different way of storing data with column-based storage than row-based traditional storage. Let's look into it a little bit further. Conceptually, a database table is a two-dimensional structure with cells organized in rows and columns. Computer memory, however, is organized as a linear structure. So to store a table in linear memory, two options exist. A row-oriented storage stores a table as a sequence of records, each of which contain the fields of one row. We can see that in this part of the screen. Conversely, in a column store, the entries of a column are stored in a contiguous memory location. You spot the difference here between these two organizations by column and row. What we basically then have in the row 1 is that A10 and the euro sign. The first row is followed by the second row, B35 $sign. And in the column store, we then have A, B, C, which is basically the three first rows of the first column. A row store should be used when you want to report on all the columns. This is an instance when the row store might be more suitable because reconstruction the complete row is one of the most expensive column store operations. On the other hand, a column store should be used when you want to fill a table with huge amount of data that should be aggregated and analyzed. So to summarize, the row-based store is good for distinct values when there are many of them, because this would lead to a low compression rate. You can, for example, think of how a zip file is compressed. What compresses best? Well, it's when there are not that many distinct values. It can also be suitable when all the columns of a table are relevant, which is more typical of an application than a report. Also when no aggregation or search is required, or if a table has a minor number of records. Which could be the case, for example, for lists or statements, system tables, and so on. On the other hand, for the column-based store, as mentioned, this should be used when we have a lot of rows and there's a large number of columns, basically when we want to use it for reporting and aggregation. Another bottleneck to avoid is data transfer. With HANA, you have a very powerful database to do the calculations. The calculation should then be done there, not in the client. So you want to move calculations into database and only transfer results. Should move away from the classical approach to the future approach. So just like in a traditional database, you can partition a table. The difference, the HANA appliers can then spread tables content across blades and work on smaller sets of data in parallel because of its in-memory clever calculation engine. But this gives further possibilities to avoid the bottlenecks in data processing. See how the parallel processing works. Here we have an illustration. The parallel processing is different in HANA in that data is only partially blocked. The full parallel processing is possible. Therefore, individual columns can be processed by different cores. And if we see in this illustration, in one query, you see the cores working their own sets of data, which may even come from two sets in one column. So the hardware technology innovations that we have seen, they include multi-core architecture, parallel scaling of blades. One blade can cost around $50,000 for an enterprise-class server, 64-bit address space, 2 terabytes of memory in current servers, 100 gigabytes of data throughput. It is by utilizing the hardware innovations that SAP can now provide the software technology innovations that we see. And this takes place in terms of the row and column store that we saw. It includes compression, as we saw in some of the customer cases, and it takes advantages of partitioning. HANA enables innovations and new ways of thinking. We need to rethink the usage of data. We have all processes that can now be improved. We have speed of thought, availability of data. There is no need for aggregation at the database level. A traditional data warehouse, it might contain costly aggregate tables, costly both in terms of storage and in terms of maintenance and modeling. We still have only seen the beginning of the usage of HANA applications. There's still a lot of usage to rethink. So HANA is not just a database. Some of the technology in HANA has been sourced from existing technologies such as BWA or the T-Rex engine. It is a powerful, groundbreaking tool because it combines business and technology. It's got the business applications and the strong hardware partners together with the software innovations that SAP provides. In a classic enterprise data warehouse, we might have multiple ERPs sitting on their own databases. We might have local data marts, each source of these ERP systems, and then we have local BI reporting on top of these. We might then also have an enterprise data warehouse, which have a database of a traditional model. We might have BWA on top of the BW system as well. And then we do corporate BI on top of this BW. Now let's look at what HANA can bring currently in SP04. We could basically have the BW replaced by HANA, or we could have BW running on top of HANA. We could have new applications that make use of HANA. We could also replace the local BI with HANA. This would speed up a lot of reporting greatly. But this is only the beginning. What we are going to see in the future should be described by this slide here. So what's planned for 2.0 is a one HANA database providing storage for both ERP, BW, and BI, or any other new application. So when we are discussing both BW, BWA, and HANA, we might ask ourselves, how does HANA compare to BWA? The HANA database has components on various other software applications. For example, the row store of the SQL parser has some code from the P-Time database, which was acquired by SAP in 2005. The column store has code from the BWA T-Rex engine. The persistence layer, the data and the log volumes, has code from MaxDB. But you shouldn't compare it to BWA. HANA is far more than BWA. For example, it's got standard interfaces such as SQL, HTTP, REST, and MDX. Also, BWA, it relies completely on BW. You can only load info cubes into BWA. Technical trivial data models can be automatically created with joins and condition, and BWA always has BW on top. Although it's powerful, it can't really exist on its own. Comparing HANA to BW wouldn't make too much sense because of the speed differences that we have seen. what does it include? What do customers get with HANA? Well, it's everything you would expect plus more. The HANA database includes SQL and MDX interfaces, the calculation engine, relational stores, persistence. It includes the HANA Studio, which we're going to see a little bit about later. It's a one-point administration and modeling tool. And it also includes the Information Composer, which is a new web-based environment that allows business and users to upload data to HANA and to manipulate it by creating information views directly. So what does it not have? Well, it doesn't have any content. It doesn't have any SAP delivered content, although rapid deployment solutions are available to populate it with content. It also doesn't have the ABAP data dictionary. It doesn't have front-end tools. There's an exception in that you can use Excel. It doesn't come with reporting tools such as business objects. Although they work very well together, when you buy HANA, it's not included in that license. So although there are some things it doesn't have, there's a wealth of things that it does include. Let's look a little bit at populating HANA with data with an RDS. We said that HANA doesn't come with delivered content, and this is one of the reasons why SAP have provided these RDS. It's a rapid deployment solution, and it delivers easy-to-deploy solutions with clear scope, predictable costs, timelines, and outcomes that you can trust. It's delivered in 3 simple phases: start, deploy, and run. And you might see there is some involvement from the customer in all these phases, such as the customer wants to get involved in some of the product management, even though it's run by SAP. They might want to get involved in part of the testing, or obviously the user acceptance testing as well. But it's essentially an RDS which is run by SAP. So with this simple and fast implementation method, you don't need a huge project to deliver results. An RDS is fast, and just as it says on the tin, rapid, as in rapid deployment solution. So this is one way of populating HANA with actual business data. This would mean content. What kind of RDSs can SAP provide? We have solutions for profitability from ERP. We have solutions for customer segmentation, ERP for accelerated finance and controlling, ERP for operational reporting. We have pipeline analysis, bank analyzer solution for financial reporting, and we also have transaction history analysis. And in the future, we're probably bound to see this list grow. What should probably be remembered is that an RDS is not the only way to populate your HANA with content. We are going to see how to do it in other ways too. So this ends lesson 1, the introduction to SAP HANA. We're now going to look at lesson 2, SAP HANA scenarios. These are examples of non-application server ABAP scenarios. In the first instance here, we can see HANA as an accelerator, which kind of means a secondary database. So as a secondary database, ABAP schemas are replicated into HANA, and then HANA then acts as a secondary database with a read-only connection. In the other instance here, we might see applications running on top of HANA. Now what this would then mean is that HANA would be the primary or only database connection. It would provide both read and write into its database. So these are two of the application server ABAP-based scenarios. We also have non-application server ABAP scenarios. Here, for example, we could have data mods with HANA. I'm going to look at this a little bit more later. Also, non-ABAP applications, standalone applications, could be run on top of HANA. Again, there it would be the primary or only database. It wouldn't be a separate server or a secondary server. So let's look at those data mods that we mentioned. What we could basically use these data mods for is to have the flexibility against change. Because of a lot of customers, they have reported that there may be only 2 or 4 slots during a year where models are allowed to change. So this is a good reason to look at the Agile data mod here. In such a data mod, it would look a little bit like a traditional data warehouse in that you would source HANA with information from, for example, the SAP Business Suite, with direct connections. You might source it from BW using ETL. You might source it from other external databases with ETL. So it would contain a lot of information just as like a data warehouse. It would then provide you with an Agile data mod. In order to do so, you would then provide transformations before loading the data into HANA. The first step would be to load these tables into HANA. Step 2 would then be to go into your HANA Studio and provide modeling. You would want to create attribute views for the different dimension tables. Attribute views we're going to come to later, but they're a little bit like master data or dimension tables. They wouldn't be useful on their own. They would also need fact tables. So this would also be the last step of using the modeler tool there by modeling the fact tables, which are then called analytical views in HANA. So this will provide us with an Agile data mod with data and results that are very easy to consume. Let's look at another scenario we could use HANA for. It might be operational data mods. Here, the data model would reflect the level of detail in data which is contained in the actual application. So here we have a database which is sourced into HANA, maybe with SLT, that's replication, or it can be sourced by ETL using the perhaps data services. The SLT would provide real-time replication of time-critical data, whereas ETL might be used when more transformations are needed. Views could then calculate results for reports in real time on the actual operational data. So why would you want an operational data mod? Well, most of the technologies currently used for operational reporting are not really suitable for the task at hand. Classical data warehouse environments are complex and may require significant effort to model operational data mods. And if operational reports hit the database directly, which run the core business applications, reduced performance may be experienced for all people working on that system. An SAP HANA-based operational data mod takes the workload of such reports away from the main database. And their replication itself, that can guarantee that the data in memory reflects the latest transactions which took place. Finally, in the memory computing, that provides very fast results, even on high volumes of detailed data. So we could say the operational data mod could provide real-time insights in what's going on in the business. Another scenario, SAP BW powered by HANA. What if you already have a BW, but you need to speed it up? You could use BWA, but you can also use HANA to power BW. DSOs or data store of this can be moved into HANA. Activation can take as much as 80% of the runtime, and this is where HANA can help. In-memory optimized DSOs, they can speed up data activations by a factor of 5 to 10. After the upgrade to BW on HANA, all DSOs, they actually remain unchanged. We have a tool for supporting converting standard DSOs into in-memory DSOs planned for the future. So the benefits might give us up to 80% time reduction. It can provide simple modeling and foster structural changes, because InfoCubes in HANA doesn't need dimensions to be physically present. Master data can connect directly with facts. Additionally, processes and all the queries are multi-provided, they can remain unchanged. So this is one way of using HANA for optimized InfoCube design in BW. When using SAP BW on top of HANA, you can also speed up existing BW IP-based planning applications. This means that from a technical point of view, no remodeling is required for these applications. The planning engine has no impact on your existing ABAP-based planning model. So if a planning function is already supported by the planning engine, the planning function will be executed in SAP HANA. Performance optimizations can be investigated to the potential that you have, or if your current planning architecture requires it, then HANA can offer huge performance improvements during runtime. How would it work in practice? Well, the planning calculations can be moved down to the database layer, thereby increasing the speed greatly. So this goes in line with what we discussed at the beginning of this unit, with the classic versus the future approach. So how does it work in practice? Let's look at this. We have some planning here. We got country and actuals and plan for the next year. Our user changes a plan value. We see here that Germany has changed the plan. It's only one country that has changed. We need to first determine the delta, 50. Now, with a traditional model, if we have per week, per branch, we might need to send 2,600 values to the database to save. Now, with the HANA-based approach, you would only send one value to the HANA database. The HANA database then would go and create and save 2,600 values. See how we use the database side and not the client side to create these processes. So this ends our first unit. So I'd like to thank you for listening to the first unit, which is the introduction and positioning